Today we're looking at section 11.3, which is on the standard normal distribution. You're going to need the other half sheet that I gave you that had the bell curve on it and a table, so make sure you have that handy. First off, we have a definition. A normal distribution uses a normal curve that has a mean and a standard deviation. We're going to be using these symbols today, your mean symbol and your standard deviation symbol, sigma. Now if you take out that table that I gave you, this is a sample of your bell curve. Your picture actually looks like this guy right here. This curve is called the normal curve. It's also called the 68, 95, 99, 7 curve. The reason why it's called that is because it's broken up into different pieces. So if you look on the bottom of your curve, some of you may have some numbers written in already. Those of you who have a clean sheet, you're going to be writing in these numbers. First thing you need to know is that halfway in the middle of your curve, you're going to have your mean symbol. That's this guy right here, right in the middle. The mean represents the halfway mark. That's 50%. So 50% of your data is below the curve, 50% of your data is above the curve. First number on this official name is the 68. That refers to 68%. So as you look at your curve, you do not have a line right here. So if I could just draw that in, that represents the 50% mark. All right, so the first line on your curve is right here. You've got a 1 underneath, and then right here, you've got a -1 underneath. From this line, red to red, this represents 68% of your data. So if I divide that in half, 68 cut in half, 34% of your data on the left, 34% on the right. So that represents your 68. So from here to here represents 68% of your data. Next number is 95. If you take 95 minus 68, which color am I in now? Green. If you take 95 minus 68, you're at 27. If you divide 27 in half, that gives you the value that will go in this next column. So that value, 13.5. So you need to write in 13.5% and 13.5% if that hasn't already been written into your chart. So from green to green, this will now represent 95% of your data. If we look at our chart, that goes from here to here. It's the second bar. That's why the 2 is underneath, and the 2 is underneath down here. So if you look underneath on your chart again, I've written in for you the 1, the 2, and the 3, but also next to that I've written this next piece. So let's go back to the column underneath the 1. This represents your standard deviation, your mean plus 1 deviation. So underneath the number 1, if it isn't already written, you need to write average plus 1 deviation. And on the left-hand side, you're going to write, underneath the -1, you're going to write average minus 1 deviation. Then go underneath your 2 and your -2. Underneath the 2, you'll write average plus 2 deviations. And then underneath the -2, average minus 2 deviations. Next number on your curve is 99.7. I'm showing that with blue. So if I go from here all the way over to here, that represents 99.7% of my data. So if you think about what we've used so far, 99.7, I've used up 95 so far. That leaves me at 4.7% of my data. Since I have 2 columns, I have to divide that number in half. 4.7 cut in half, 2.35. So the next number underneath your chart is going to be 2.35. You can go ahead and write in 2.35%, 2.35%. And then underneath your -3, put mean minus 3 deviations. And underneath your +3, it should say mean plus 3 deviations. Now that leaves us the little teeny piece of the tail of the graph that's way over here. and way over here. Well, we've used up 99.7% of our curve so far. That leaves 0.3% of the curve left. And if you divide 0.3 in half, those are the two little leftovers. So I've got 0.15% left and 0.15% left. That's the little teeny piece on the very far left and far right. Now, as I mentioned with your Pascal's triangle, you get to use this curve when you're doing your homework tests and so on. So you want to have this with you, and you want to have all of these percent values in here. So the 34s, 13.5s are next, 2.35, and then on the far outside, 0.15%. And then these numbers down below, starting with mean, average +1, average +2, average +3 deviations, and then average -1, average -2, and average -3 deviations. Now, how are you going to use this curve? The book is going to give you questions that are going to look like this. Now remember, P stands for probability. What's the probability that, if you recognize this notation, this is a betweenness. This is a between question. So where is X between average -1 deviation and average +3 deviations? So if you go back to your chart, I need to identify average -1 and average +3. So let's go back to our bell, and I need to look to see where is average -1, right here, and average +3 is way over here. So I need to know what's the chance that my probability will be between average -1 and average +3. That means I have to add up these particular percentages. So if you put your hands on these curves, on these lines, you'll see that you're going to be between here and average +3 is right here. So I need to add up 34, 34, 13.5, and 2.35. So my probability that I'm between average -1 and average +3, 0.34, 0.34, 2.35, and 0.15. I'm going to take the decimal points out of here, make it easy. So it's 34, 34, 2.35, and 0.15. Add that together, and you'll come up with your probability, 83.85. Now, if you want to show this as an entire decimal, you can do that as well, but just be careful. This would be 0.34, 0.34, 0.0235, 0.0015. You might get more confused that way. So I would suggest you just leave it as the numbers as they show on your curve, 34, 34, 2.35, and 0.15. And then remember, you're looking for a probability, so when you're done, 83.85, tack your percent sign on there as well. Scores on an exam have a mean of 200 and a standard deviation of 20. What percent score lower than 160? What percent score above 220? The other time, or the other place that you can use these bell curves would be to answer questions like this. So if you do see a question that involves data like this, see if you can draw your own curve and place your values on your curve. Scores on an exam have a mean of 200. Mean is the number in the middle, so I know that right in the middle I'm at 200. If it says that the standard deviation is 20, that means each of my bars I have to add 20 going up and subtract 20 going down. So the first line would be average +1, 220. My second line would be average +2 deviations, 240. And my third line, average +3 deviations, 260. And then I can do the same thing going backwards. Average -1 deviation is 180. Average -2 is 160. And average -3 is 140. So these would be the numbers underneath my curve. Then I can go ahead and answer the question. What percent score less than 160? 160 is right here, but you need to remember, where were we? We were at average -2 deviations. So if the question is asking me what percent score lower than 160, I'm going to go back to my bell curve. I'm going to look for the average minus 2 line and take everything that's lower than that. So let's go back to our curve real quick. Look for average minus 2. Average minus 2 is right here. And if I need everything lower than that, my values are 2.35 and 0.15. 2.35 and 0.15. 2.5%. So what percent will score lower than 160? 2.5%. Part B, what percent score above 220? So now I look at my curve. I look to see where I'm at 220, which is right here, and this line is at average plus 1 deviation. I'm looking for what percent will score above 220, so I need all of these values higher than average plus 1. So if I go back to my bell curve and I look for average plus 1 right here, and I need to have everything higher than that, 13.5, 2.35, 0.15. 13.5, 2.35, and 0.15. And when I add all of those together, 16%. What percent will score above 220? 16%. So you need to, in some instances, you need to draw your own bell curve, put in your own values on the bottom, and then match up your picture with your clean bell curve that has the percent values next to it. What happens if your values don't fall right on one of these bars, right on average plus 1 or average minus 2? Then you have to do what's called a z-score. If your values do not fall right on a standard normal curve, you must find a z-score. Then you'll take your z-score to what's called a normal distribution table. That's the top part of the half sheet that I gave you. So your bell curve is on the bottom, your standard normal distribution table is on the top. The formula that you need to know is right here for a z-score. Z-score is x minus mean divided by sigma. Your number minus the average divided by standard deviation. You need to get this in your notes, and you need to put this on your cheat sheet for your final as well. What we're going to do now is go through a question together. This is page 759, question number 8. This question comes from example number 3. Scientists conducted aerial surveys of a seal sanctuary, recorded the number of seals they observed during each survey. The number of seals observed were normally distributed with a mean of 73, so our average is 73. Standard deviation is 14.1. Find the probability that at most 50 seals were observed during the survey. That's example number 3. Now if I look below at question number 8, it asks, find the probability that at most 90 seals were observed during a survey. At most 90 seals were observed. At most means it can go up to 90 but not go over. So that's x less than or equal to 90. So if I use my z-score, and remember your z-score formula, your number minus the average over standard deviation. X minus average over standard deviation. So they asked me, what's the probability that my number is less than or equal to 90? So my number is 90. I need to start with my number. Then I subtract the mean, divide by 14.1. We're going to come up with a decimal value. In this case, our decimal value is 1.2. So I need to know how to translate this. What do I do with this number? Well, I need to go to my normal distribution table. If you look on the far left-hand side of your table, you see 0 and negative 0. The 0, 1, 2, 3 represent positive values, and the negative 0 represents any of the negative numbers you could get when you do this division. Negative 0, negative 1, negative 2, and negative 3, and so on. Up at the top, we've got tenths that we're going to be looking at. Now, some of our numbers aren't going to be exactly on tenths, so we're going to have to round. And when we round, we're going to be dealing with that 0.5 is the halfway mark, so anything 0.5 and above will round up. Anything below 0.5 will round down. The number that we have to deal with, I believe, was 1.2. So we're going to look at our table. We're going to go to positive 1. We had positive 1.2. So we're going to go to positive 1. Positive 1 is right here, and 1.2 would be right here. So we're going to go across to 0.2, and this value will be the number that you're going to be looking for. 0.8849. So my probability that I am less than or equal to 90, 0.8849. You can leave these numbers. You don't have to change them if you don't want to. If you do, make sure you move your decimal 2 points to the right, and make sure you put a decimal or the percent sign on there as well. 20 colleges found that the average credit debt was $34.50. This value is normally distributed, standard deviation of 1175. Find the probability that a person's debt was at most $3,600. We need to find a z-score. Our number minus the average over standard deviation. Our number, 3,600. The average, 3450. And our standard deviation, 1175. When you do your subtracting and divide by 1175, you get 0.127. So now I take 0.127 and I go back to my table. 0.127, positive 1, positive 0, I'm at 0.127. So this is like 0.127. So I need to go to the 0, positive 0, and 0.1 will be between the 0.1 and 0.2. Since my next value is less than 5, I need to use the 0.1 number right here, 5398. So the probability that we are at most 3,600, 5398, or you could say 53.98%. The one time that you have to be very careful is if you see the phrase at least, if they're looking for a probability that x is at least a number, or if you see the symbol greater than or equal to, then you actually have to do one extra step, and that's the complement. So if you can remember, in the last chapter we did complement. Complement is 1 minus what the original was that we were looking for. We have to do that if you ever see the phrase at least or x is greater than or equal to. So again, your steps, you're going to do the z-score first. You'll take the z-score to the table, but then here's where you're going to do that one extra piece, 1 minus the number that you get in the table. So if we look at this same college question, but instead of saying what's the probability that we're less than or equal to 3,600, we're going to do greater than or equal to instead. So our situation is the same, z-score, our number minus average over standard deviation. Our number again is 3,600. The standard deviation, let's go back for a second. Standard deviation was 1175, but our mean was 3450. So we're going to subtract 3450. We'll be dividing by 1175, and if you can remember what our number was, 0.127. We took that 0.127 number to our table. We got a table value of 0.5398, and it is at this point that we do the complement, 1 minus 0.5398, and this will give us our probability, 4602. Or you could write it as 46.02% that we are greater than or equal to 3,600. So this rule right here is something that you probably want to put on your cheat sheet. Anytime you're going to be doing a probability and you see the phrase at least, or if it's the greater than or equal to, you must do the one extra step of the complement in the last step after you take your z-score to your table number, then do your complement. All right, that's it for section 11.3 with your bell curve and the standard normal distribution table.